Guys, welcome back to our channel Vansh Patel Academy. In this video, we are going to do a chapter number 9, Light of class 10th Science. Okay, so this is the part 1 video of chapter number 9, Light. In this video, we are going to cover the topics like okay students, wait for reflection of light, law of reflection, refraction, refractive index, law of refraction. There are two laws, Snell's law and second law, bending tendency of light, the basics of mirror and lens. Okay, mirror, lens, the important terms which are going to be there in a mirror, lens and spherical mirrors, and standard laws of concave mirror and ray diagrams of concave mirror. And the remaining topics like standard laws of convex mirror, ray diagram of convex mirror, lens, then law of convex lens, law of concave lens, and ray diagram of convex concave lens, and some important formulas, as well as the most IMP thing, sign conversion. These 4 to 5 topics we will cover in part 2. Sorry students for a disturbance. Now let's start with our video light. Let's start with our chapter light. Okay, so first of all, let me know in the comment box what you mean by light. Yes, light is a ray. Light pass in straight line only. It cannot move like this. This is light. Light cannot move like this. It will be always in the straight form. Okay, light is a ray which is always in the straight form. Okay, first of all, let's start with reflection of law. What is reflection? The bouncing back of light from the polished surface. You can see I have made a diagram also. This is the polished surface, students. This is the polished surface. And the ray is coming and reflecting back to the other in the same medium in the other side. Okay, so this is the reflection of light. Bouncing back of the light from the polished surface, it's called reflection of light. Now you have studied this in the 9th standard, so we are not going deeply. Now let's see the law of reflection. The angle of incidence is equal to the angle of reflection. Angle of incident, reflected and normal lie on the same plane. The first law says the angle of incident is equal to angle of reflection. That means the angle of incident means this. The angle of incident is equal to angle of reflection. For example, angle of incident is 40, then angle of reflection will be also 40. So the distance between or angle between them will be always 40, or you can say they are same. Then the second law says incident ray, reflected ray normally lie on the same plane. They all lie on the same plane at the same point. You can see the diagram also. Now let's start with refraction. What do you mean by refraction? The bending of light when it enters in the one medium to the another medium. There are lots of medium, students. There are lots of medium. For example, air is a medium, water is a medium, alcohol is a medium. Okay, so they are saying when a ray, this is the example of bending of light. Okay, you can see light is coming, it bend towards the upward, and further it also bend in a straight line. So this is bending of light. So when a light ray is coming from the air and when it's enter in water, it will change its path in certain direction. You can see the light ray coming, when it collide with this point, it change its direction, and then it collide with here, collide with C point, collide with C point. This is B point. When it collide with C point, it change its direction one more time. So this is the example of, okay, I have rough. Okay. Okay, students, I hope that is clear to you all. When a light ray change its path when it enter in the different mediums. So this is the example and the definition of refraction. Now, the incident ray and emergent ray. Students, remember this. This is known as incident ray. This is known as refracted ray. This is known as refracted ray. Refracted ray. And this is known as emergent ray. This is known as emergent ray. Okay, students, this is known as emergent ray. The angle of incident is always equal to the angle of emergent, and angle of incident is parallel to the angle of incident. So these are the two laws, not a law but a basic things that you can mention the difference. Okay, now let's see what is refractive index. The comparison of a medium 1 to the medium 2. The simple definition is that the comparison of medium 1 to the medium 2 is known as refractive index. We are comparing, for example, we are comparing Virat Kohli to Rohit Sharma. This is called refractive index, but in the term of cricket. But we are going to do a refractive index in a term of light, in a term of medium. Okay, what is refractive index? Let's see definition. Refractive index depend on the medium. It's need medium. Okay, for and the ratio of the velocity of light in the vacuum or in a specific medium. Okay, so it says they are comparing the mediums. For example, vacuum upon air, air upon water. So this is called refractive index. Comparison between the two mediums is called refractive index. Okay, I hope that is clear to you all. The formula is medium 1 upon medium 2, medium 1 upon medium 2. Okay, medium 1 upon medium 2. C upon V, you can also write like this, C upon V, where the value, if there are two types of, okay, students, there are two types of refractive index, absolute and relative index, and I have not written. Okay, leave it. Absolute refractive index. What is meant by absolute and relative? Absolute means we are comparing any other medium to the vacuum only. Vacuum upon air, vacuum upon water. There will be always vacuum will be there, in which the ratio of vacuum upon any other medium, it is known as absolute refractive index. While in relative index, you can take any medium in the numerator as well as the denominator. For example, water upon air, air upon water, then oil upon water. Okay, students. So absolute refractive index means you are comparing the other medium to the vacuum only. It is known as reflective and absolute reflective index. And the speed of light in vacuum is 3 into 10 raised to power 8. So this is the IMP value. You can remember. You have to remember that. Now, law of refraction. First law, Snell's law. A scientist Snell's had discovered this Snell's law. Ratio of single angle of I to the sine angle of reflection. A ratio of sine angle of incident to the sine angle of refraction. Okay, that means we are comparing the ratio of sine angle I upon sine angle R. So this is the formula, and which is constant. Always it will be constant. Okay, Now let's see the second law. What the second law states? Second law states they in the first law in the second law of reflection of light, we see the incident reflected normal lie on the same plane, but you have to just remove the reflection, but you have to add the refraction. That means normal, incident and refracted ray lie on the same plane at point of incidence. That means you can write the definition also in your book. Let's understand with the diagram. For example, this is the shining surface. Light ray is coming. Okay, now we are doing the glass slab. This is the ray is coming. This is known as angle of incidence. Okay, this is the normal, and when it enter in different medium, it will bend it to the normal and pass outside with the another side. So you can see that the incident, normal and refracted ray are pointing at they are meeting at this one point. That point is known as point of incidence. Okay, I hope that is clear to you all. Now let's start with the bending tendency. How you can know where the light will bend towards the normal or will go away from the normal? See students, light ray always go far away from the normal in the case of water. Okay, in the case of air, while it will always concentrate to the denser medium. For example, it will always concentrate to the water and it will come towards the normal. You can see in the diagram also. This is the incident ray coming from the air. Okay, this is normal and it is coming towards the normal. When it entered in the water medium, it is coming towards the normal. Okay, and the angle of incident is bigger than the angle of refracted. Angle of refraction is smaller than the angle of incidence. Okay, so in air, go away, while in water, okay, I have written also here. Why I am writing? I have written also here that water is equal to come to normal, while air go away from the normal. Okay, you can see the diagram also. The light rays coming from the water, when it transfer the medium or come in the air, it go away from the normal. Now let's start with lens and mirror. First of all, mirror. Plane mirror. What is plane mirror? We use plane mirror in our daily to daily life. You are watching yourself. You are for example, after taking the bath, you come to the mirror and see yourself in it. It is plane mirror. Then concave mirror, then convex mirror, then concave lens, then convex lens. We will all study about the concave, convex, lens, mirror, everything, and what are their uses as well as their law and ray diagram also. Now first of all, the basics of mirror are the concave. The concave mirror is converging, while convex mirror is diverging. It means it converge all the ray at the same point in concave, while in the convex the ray are diverge. Okay, so this is the simple concept. Now let's see in the lens. In lens, convex students, don't be confusing lens and mirror. In lens, convex lens is converging, while the concave lens is diverging. Now some important terms are mirror or a lens are Principal axis, principal focus, center of curvature, radius of curvature, focal length, and pole. You can see this is the mirror, this is the mirror, this is shining surface, and this is opaque surface. Now when a center of the reflecting surface, it is known as pole. For example, this is pole. The center of the reflecting surface is called pole. Now at the point where all the light ray are point at the same point, it is known as focus. This is focus, students. All the light ray, if you follow all the light ray in the parallel to the principal axis, then it will be all concentrate to the focus. So it is known as focus. The distance between the focus and the pole, it is known as focal length. So we have done pole, focal length. Now a ray which is passing through the pole to the center of curvature is known as principal axis. We have done principal axis, focus, focal length, and pole. Now what is center of curvature? Students, for example, this is the sphere, and this is the center of the sphere. So if you cut this sphere in the two parts, you will get one concave mirror. This is convex mirror, while this is concave mirror. One concave mirror and one convex mirror. Okay, and while this is the center of curvature, you can tell like center of sphere also, but initially you have to tell center of curvature. Okay, so I hope that is clear to you what is center of curvature. Now the distance between the center of curvature to the pole, it is known as radius of curvature. Now let's start with some important terms of plane mirror. The plane mirror plays an image virtually erect, same distance in the mirror and the object, same size, laterally inverted. Okay, for example, if you are standing 10 meter away from the mirror, then the image will also 10 meter far away from the mirror. That the distance between you and image. For example, this is you, this is mirror, and this is you. This is your image. This is 10 centimeter. This is also the 10 centimeter, and the distance between both will be the 20 centimeter. Okay, so this is the first thing. Then it is virtually erect. I hope that is clear to you all. Virtually erect and the same size. For example, your height is 5 foot. This is the mirror, and the image will be also of a 5 foot. Also will be of the 5 foot. Okay, now laterally inverted. What is laterally inverted? For example, if you stand up your if you have taken up your left hand, then in the mirror your right hand will be there. Okay, now without wasting your time, let's start with standard laws of concave mirror. So the first law of concave mirror states, when a light ray is parallel to the principal axis, it will pass through the focus. When it will be the parallel to the principal axis, then it will pass through the focus. Now the second law states when a ray passing through the focus, it will be parallel to the principal. That it is the opposite of first law only. Okay, here the incident ray is parallel to the principal axis and cutting the focus, while here the incident ray is cutting the focus and reflected ray is parallel to the principal axis. Now the third law. When a ray strike the pole, it will be reflected in the same medium at the same angle of for example, the incident angle is 40, then the reflected angle will also 40. It will reflect in the same medium at the same angle. Now let's do the fourth law. What the fourth law states? what the fourth law states. When any light ray pass from the center of curvature, it will be back in the same way. That means, for example, light ray is coming from here, it cutting the center of curvature, okay, this is center of curvature, cutting the center of curvature, it will reflected back from the same path, and it will reflected back and cut also the center of curvature twice. It will cut the center of curvature twice. First of all, the incident will cut the center of curvature, and reflected ray also cut the center of curvature. So here we have learned the four standard laws of concave mirror. So till here we have done reflection of light, refraction, refractive index, law of refraction, bending tendency, some basic laws of mirror and the lens, then the important terms, then about the plane mirror and the laws of concave mirror. I hope that is clear that the four laws are there. First, the rays parallel to the principal axis will reflect it back and cut the focus. Second, a ray cut the focus will parallel to the principal axis. Third, when a ray strike at the pole, it will be back in the same medium with the same angle between the incident and the reflected. And the fourth, when it pass through the curvature, it will reflected in the same medium to the curvature. Now let's start with ray diagram. So that these are the most IMP thing in this chapter, because most of the questions come from the standard laws of concave mirror and standard laws of convex lens and the ray diagram of both. So let's start with first ray diagram. If we place the object at infinity, that means we are putting the object at infinity, then the two light rays, this is first and this is second, they will meet at the point, that point the image will be formed. Okay, this is the parallel to the, this ray is parallel to the principal axis, then it will be passed to the focus. We have studied in the standard laws, it will pass to the focus. Now this is also the parallel to the principal axis, then it will also pass through the focus only. Then the image, our image is at focus, position of the image is at focus. Okay, so you have to learn the position of the image and the position of the object also, and the nature, that is real inverted, highly diminished or a diminished or enlarged. Okay, now the second case, this is the first case where we are putting the object at infinite. Now second case, in second case we are putting the object behind the center of curvature, okay, always the one ray will be parallel to the principal axis and pass through the focus only. So this is the first ray. And the second ray, we have studied the second standard law, that if a ray cut the focus, then it will be the parallel to the principal axis. Now the image, both the light ray are intersecting at this point, so the image will form over here, between the C and F, you can see between the C and F. So the nature of the image are real, inverted and diminished. Okay, in all the ray diagrams, the nature of the image will always real and inverted except the last ray diagram. You can see here that virtually that baki or in the other 5 there are real inverted, and real inverted. Okay, so that is easy for you. Now we have studied first law and the first ray diagram and second ray diagram. Let's start with third ray diagram. In third ray diagram, we are putting our object at the C. Let's put it. We have put an object at the C. First ray will be always parallel to the principal axis and pass through the focus, going. Okay. Then the second ray will pass through the focus and parallel to the principal axis. Then the both ray are meeting at this point. So image will be formed over here. Where it is forming? It is forming at the C. It is position of the image is at the C, and the same size of the image will be there as the size of the object is there. It is real inverted. Okay, so this is the nature of the image at the object at C. Now let's start with fourth case where we are putting the object at the between C and F. In previous we have put it at the C. Now let's put at the C. We put it. Now first ray will be always always parallel to the principal axis and pass to the focus only. Remember students, first ray will be always pass through the focus only and parallel to the principal axis. Wait students, yes. Sorry students. Yes, it will pass through the focus only. Okay, now the second ray, we have learned the fourth law where a ray which is coming from the center of curvature will always reflected back and come to the center of curvature only. It is coming from center of curvature and going from the center of curvature. So first ray is parallel to the principal axis. Parallel to the principal axis and cut the focus. And the second ray coming from the center of curvature and passing from the center of curvature. The intersection of the both of the point is this, beyond the C. So the image will be formed at the beyond the C. You can see I have written also here, beyond the C. The nature of the image will be real inverted and enlarged. Now let's do the fifth case. In fifth case, we are putting our object at F. So let's put it. First ray always the parallel to the principal axis and pass from the focus. Now at the second ray will come from the center of curvature and go from the center of curvature. You can see the student, there is a difference between them. That means this is infinite. They are parallel to each other. So they will not meet anywhere. So they will go further. That means they will never meet, and the position of the object will at infinity. You can see at infinity. Now we have done the fifth case also. Now let's start with the last case, which is exception. Okay, the object between P and F. F means focus and P means pole. This is pole and this is focus. This is focus. Our object will be between them. The first ray in here, there will be no any type of ray which is parallel to the principal axis and cutting the focus. The first ray will be coming from the center of curvature and going from the center of curvature only. Now we have learned the third law. That law will be applicable over here. The light rays striking at the pole and reflecting back in the same medium with the same angle of incident and angle of reflection. So you can see the image is not forming over here. Image is not forming because both the ray are not meeting at any point. So we have to make the imaginary line. See, both the imaginary not a real. Imaginary, students, imaginary, this word is most important. Imaginary image is forming here. So this is the position of the image behind the mirror, behind the mirror, and it will be enlarged and virtual erect. So we have done standard laws of concave, and with the help of standard laws of concave mirror, we have done the ray diagram of concave mirror. Now I know that you all felt difficulties to remember the position of the object as well as the position of the focus. So for you all, I have made the shortcut tree. First of all, arrange all the position of the object. What is the position of the object? At infinity, at C, behind C, at C, then between CF, at F, between P and F. So arrange them. Now put in the sequence. First of all, if the object at infinity, then it will be meet at the focus. Now at the focus, the image will be form at infinity. So opposite cases are there. In infinity, focus will be there. In focus, infinity will be there. Opposite cases are there. Now second one, beyond C, between CF. Now between CF, beyond C, you can see. Now at the C. So at the C will be same. Okay, there will be no any type of, you have to remember. So from this way you can remember easily the things, but you have to learn that between P and F, if the object will be there between P and F, then it will be the always behind the mirror, and in the first five, the image will be real and, sorry students, real and inverted. But in the last case, it will be virtual. Students, not okay. I hope that it is visible to you all. Virtual erect. Okay, so you can learn all the things by very easy manner by making the shortcut tree to remember them, and for example, this is the mirror, this is pole, center of curvature and focus. Object at infinity, the light ray will come from the focus. I am not making any type of rays, so image will form over focus. Image 1, I am writing image 1. Now the image 2, let's write image 2. Image 2 will form beyond the C, then it will be the at between C and F. Image 2. Now image at C. Now if the image is at C, then the image will form at C only. Now image at C and F, that image 4, then it will form behind the C, image 4. Then the image 5 is forming over the focus, then the image 5 at the infinity. Image 6 forming between the P and F, then the image 6 will made over here. Okay, so here is the shortcut tree to remember all the position of the image and object. So here we have end the part 1. I hope that you have liked the video. If you like, then like, share and subscribe this channel. तब तक के लिए जय हिंद, जय भारत.